In this video, I'm going to explain the Boyer-Moore pattern matching algorithm. Generally, the pattern matching is a computational technique used to find the occurrence of a pattern in a given string. For example, let's say we have a given string that was nice. This is the string, and we need to find the word was in the given string. The string that was nice is called the text and was is called the pattern. The pattern to be searched in the given string. That is the searching algorithm. And out of many algorithms, Boyer-Moore is one of the algorithms that gives a time complexity of order of m by n in the best case and order of m into n in the worst case. With this little background, we will now see the algorithm, how it works. To understand the algorithm, we have taken an example of a string. This is a sample text. We have taken the example of string as this is a sample text, and the pattern to be searched is a sample. And string, this is a sample text is denoted by T, for example, and the pattern is denoted by P. So length of the text is 17 characters and the length of the pattern is of 7 characters. The entire algorithm, the Boyer-Moore algorithm, is based on the two concepts. One is called the bad match heuristic, and second one is the good shift heuristic. In order to implement Boyer-Moore algorithm, what we do, we'll create a table for the pattern. We'll create a table for the pattern. Let's see how to create this table. First of all, the pattern, this is the pattern P, and these are the index 0, 1, 2, 3, 4, 5, 6, and 7. And here we consider an array of string and index starting from 0, 1, 2, 3, and total there are 7 characters, and last place we kept it as star. Star indicates that any character other than the characters in this pattern is considered as a star character. First of all, to fill this table, we need to put certain values in the row here. In order to fill this value, we will be using a formula. Let's say this row is known as value. There is bad match value, for example. So how I will calculate the bad match value for A, say. So what we will do, the bad match value for A, the value of A is calculated as length of P minus index of A minus 1. In this example, the length of P is 7. Length of P is 7. Index of A is 0. Minus 0 minus 1, which is equals to 6. We'll put this value 6 here. To calculate the value of S, the second character, it will be 7 minus 1 minus 1, which is equals to 5. This way, value of A is appearing here second time. So value of A is equals to 7 minus 2 minus 1, which is equals to 4. At this point, we have S is equals to 5, A is equals to 4. That way, if we compute the values for M, P, and L, it will be 3, 2, and 1. Now, since we have encountered A twice, here 1, here is the second one. So in this case, what we will do, we will keep the second occurrence of A. If it occurs third time, then we will consider the third occurrence. So in this case, what we will do, we'll keep the value of A is 4 and we will cross out this value. Now it is interesting part here. When we take the last character, the batmatch value for the last character E, we do not calculate using this formula. We do not use this formula to calculate the value for the last character. So the last character, the value for the last character is always the length of the pattern, which is equals to 7 here. Similarly, the star indicates any character other than this set of characters in the pattern, and that value is also taken as the length of the pattern 7. One more thing that we need to remember is, let us suppose that the last character E appears multiple number of times. In that case, what we will do, we'll consider always the value of the last character as equals to the length of the pattern other than any other value in that we encounter or we compute during the process of batmatch table creation. So with that value, we have created the batmatch table, and that batmatch table is next to be used for comparing the pattern or to find out whether the given pattern is available in the string or not. Here, a sample, we have created the batmatch table for a sample, that is the pattern, and now we will use this batmatch table in order to find whether a sample exists in the given text T or not. Let's see that. So this is the batmatch table for the given pattern that we have created. Then this is the string that where we need to find out the pattern. So we'll put the leftmost character of the pattern in line with the leftmost character of the string, and we will place the rest of the characters accordingly. A is coming under T, the first character, then second character, third character, fourth, fifth, sixth, and seventh. All characters are placed. The 7 characters of the pattern is placed under the first 7 characters or leftmost 7 characters of the. Then we will compare from the right hand side. We'll compare from the right hand side. A in the string is not matching with the pattern in the string. So since there is a mismatch, what you will do, we will go to the batmatch table. Batmatch table will see the value of A. What is the batmatch value for A? Batmatch value for A is 4. We will shift the pattern by 4 characters. Now we will shift the pattern by 4 characters. But however, while shifting 4 characters, we will not consider the first character with which we have actually placed the pattern. So we'll count from the second character 1, 2, 3, and 4. So in the next iteration, the first character of the pattern will come under I. We'll repeat the same procedure. Let's say this is iteration 1 and iteration 2. In iteration 2, according to the batmatch table, what we did, since here A is not matched, so the batmatch value for A is 4. That's why we'll right shift the pattern 4 characters, and starting from the second characters 1, 2, 3, 4. So next, in second iteration, A, the first or leftmost character of the sample, will be placed under I. We'll continue again. Then we'll compare the rightmost character E with the rightmost character P of the main string or the text, and we see that there is a mismatch. Since there is a mismatch, what we will do, we will go to the batmatch table, see the value of P. Value of the batmatch value for P is equals to 2. That's why we need to move 2 characters towards right. The pattern to be moved 2 characters towards right. So in order to do that, since we have taken this one as for comparison, so we'll count from the next character as this 1, this is 2. Next time, in the third iteration, first character of the pattern, which is A, will be placed under the character A of the main string. So this is the new placement in iteration 3. Now we will start comparing from the rightmost character. So E is matching with E. Then we will move to the next rightmost character L. L is matching with L. Then we will move both the pointers here. P will be compared with P, M with M, A with A, S with S, and A with A. So now here the complete matching of the pattern is found in the given string, and this completes the iteration of the program. Once the pattern is matched with the string, next, where does the pattern occurs? At this place the pattern occurs. And in the main string, if I take the index, this is 0, 1, 14, 15, and 16. These are the indexes of the string. When we compare these two strings, we take a pointer I in the main string and we take a pointer j in the main string. We compare the value of I, which is equals to 12, is compared with j, which is equals to 6. So if they match, E is matching with E, then we will decrement I to the next character L, and here j will also be decremented to point to the previous character. Again there is a match, so we will decrement I to point here, then decrement j to point P, both are matching. Again we will decrement I, again we'll decrement j, matching, decrement I, decrement j, matching, decrement I, decrement j, matching, again decrement I and decrement j. But beyond that, if I decrement I, it will point to S, fifth place, and j will point to -1. So at this point, the algorithm will terminate. Now, if I take the value of I is equals to I plus 1, that is 6. That means it specifies I is equals to 6 is the place where the pattern matches or pattern appears. So finally what we can conclude, that pattern A sample appears in the main text in position 6. That is how we can find out the position of the string in a given string using Boyer-Moore algorithm, pattern matching algorithm. One important point in this algorithm, we can see here we have a star character, and the value of the star character is given as the length of the pattern 7. So when to use this value 7, or when to use this character star? Let's say during the execution of the algorithm, the E, that is the last character of the pattern, is placed under the character T in the main text or the string. E is not matching with E. So we will go to the bad match table and we look for the character T, but we do not have the T here in the table. That's why we'll consider star as the character. So the value for this star is equals to 7. So what we need to do, we will move this pattern 7 characters or 7 places in the main text. So 1, 2, 3, 4, 5, 6, and 7. That is, in the next iteration, we will place the pattern starting A just below T. So that is the use of the character star. So star means any character which is not available in the bad match table will be considered as star, and that value, bad match value, will be considered for shifting the pattern. So this is one important point that we need to remember during the execution, and if you follow this approach, then we will get the uh, result of the pattern.